We will be taking up another session now on in real numbers. Today we'll be learning out on applying this Euclid's lemma or Euclid's algorithm to find the HCF of any two given numbers. Let us first understand how to go for that, and then take up examples solving or finding out the HCF. Suppose there are two given numbers A and B. Now A being greater than B, we will be first expressing A as explained in lemma. It is BQ plus R. Now this R, if it is not 0, can be now referred to as R1. We are actually trying to find out till we get this R0, the remainder should be 0. In this case, I am assuming that the first step, the remainder is not 0, and referring that as R1. Now the second step becomes this B comes down, and that is expressed in terms of R1. So it becomes R1Q plus R2. Again, suppose at this stage you are still left with the remainder, which is I'm referring here as R2. So we move on to the third step, wherein this is represented as R1 in terms of Q, so that you get maybe R3. Now if it's R1 will be in terms of R2Q, and this is then Q1, this is Q2, this is Q3, plus maybe R3, this is the third remainder. It continues, you continue with this as many steps as till you get this R to be 0. These are the steps. First, you'd express this given two numbers in terms of the Euclid's lemma. Then you continue these lemma steps till you get this R0. Let me take up an example to make this explaining part clear. It says, the question might read as Euclid's division, I'm just writing division algorithm to find the HCF. I'm skipping that E part to shorten it up, of 210 and 55. So you start representing as, because 210 is greater, I'll be expressing 200 terms 10 in terms of 55. So if you divide 210 of 55, this is 55, 3 is giving you 165, so we're left with 45. Okay, so it is 55 into 3, and the remainder was 45. So if you try to fix it up with the one I had given the formula, this becomes A, this is your B, this becomes your Q1, and this is now R1. This is for you to only understand for first explanation, then later on when you start taking up questions you can skip this part. Now the second step being, you have to take it up B. So the B was given as 55. 55 will be expressed in terms of R1, so that is 45 into QT, that Q2, that will be 1, and plus the remainder, this is R2. So I write it here, this is B, this is R1, this is Q2, and this is R2. The next step is now to express R1, that is 45, in terms of R2, that is 10 into 4, that is plus 5. So this again is R1, this is this is R2, and this is Q3, and again there is a R3. We will be now expressing R2, that is 10, in terms of R3, that is 5, and the Q4 becomes 2, and thereby making the remainder 0. So here I am expressing, this is R2, This becomes your quotient 4. This is R3, and now the remainder is 0. This is R4. So the point at which R, the remainder, is 0, we see this as B. This, because this is again expressed in terms of A equals to BQ plus R. So what is B here? The B stands here, the 5 stands for B. So HCF of these two given numbers can be taken as 5. This can be one application. Another, let me take up one more question. I'll just write it down first. Oh, sorry. Find the largest number that divides 2053 and 967 and leaves a remainder of 5 and 7 respectively. That means for the first number there is a remainder of 5, and for the second one there should be a remainder of 7. We have to then find a number that is leaving a remainder for 5023 as 5. That means the number which I get after subtracting 5 from 2053 will be the number completely divisible. And similarly, if I am subtracting 7 from 967, I will be getting that number which is completely divisible without leaving any remainder. So if I do 2053 minus 5, I'll be getting 048, and obviously 967 minus 7 gives me 960. So these are the numbers which are exactly divisible by the number which we will be calculating. As because it is asking for the largest number, we'll be finding the HCF of 2048 and 960 by applying the division lemma, or the algorithm. So as because 2048 is greater, I'll take that up first. So 2048 is equal to 960 into something plus 4. So 960 I think into 2 gives you 1920. Okay, so the remainder I'm getting is 128. I'll continue this process till I get a 0. Now 960 will be expressed in terms of 128. 960. Am I leaving any remainder or not? 960 into 2 plus 128 is giving me, that is right. So it is 128 into 7 gives me 896. That's leaving me a remainder with, sorry, it's not remainder, obviously it is 896. So 960 gives me 64 again as a remainder. Now 128 is 64 into 2. Now here I'm getting a remainder 0. So HCF of these two numbers becomes 64. That means 64 is the number which divides 2053 and 967 and leaves a remainder of 5 and 7 in respective cases. This can be another application. Okay, I can give you one question for your practice. Maybe you can try this by yourself. I write it down for you and then I take another question. Find the largest number which divides 245 and 1029 leaving remainder 5 in each case. That means you have 5 in both the cases, so subtract 5 from both of them. Once you find, I can give you the answer for your confirmed checking. You will get the answer to be 16. 16 will be the largest number which divides these two given numbers and leave a remainder of 5 in each case. I move on to another question. Okay, I'll just write it down. I know it's a little longer one, so I'll might just be using some short forms to complete it in shorter time. In a seminar, the number of participants in Hindi, English and maths are 60, 84 and 108 respectively. Find the minimum number of rooms required if in each room the same number of participants are to be, ignore it, to be seated. There is a mistake wherein I have written 2 T's. All of them they sit in a same room and all of them being in the same subject. What we do, the number of participants in each room must be what? The number of participants, that is 60, 80 and 108. If you find the HCF of these 3 numbers, that will give you the number of participants in each room. So how do you do it when there are 3 numbers to find out? We have 3 numbers in Euclid's division algorithm. Take 2 these numbers first, find the HCF, and then with the same HCF you can take it up with the next number. So we have to find HCF of all this number to find out the maximum number of participants to be seated in each room. So let me just take up the first 2 numbers, that is 60 and 84. I could be using a thinner line to solve this. 84 being the greater number, we will be expressing that in terms of 60. So it is 60 into 1 plus 24. We'll express 60 in terms of 24. 24 into 2 is 48 plus 12. There is a 60 expressed in terms of 24 into 2, that's giving me 48 and 12. So now I'll be expressing 24 in terms of 12. So 12 into 2, 24, that is 0. So the HCF of 60 and 84 is giving me some 12. I'll take this along with 108. So I'll 12 and 108. This becomes easy. I know it is 108 when expressed in terms of 12. 12 into 9 is 108 plus 0. So 12 is the HCF of these 3 numbers. Now if 12 is the maximum number of participants seated, what is the total number of participants? 60 plus 84 plus 108, that's giving me 144, and 108, that's giving me 252. So the number of participants in each can be 12, in each room will be 12, and there are total number of participants being 258. So the number of rooms we need because it's asking find a minimum number of rooms required. So the minimum number of rooms will be 252 upon 12, that's giving I think 21. This will be the number of rooms required. Okay, this is not as much difficult. I give you another question on the similar note for you to practice. It says 2 tankers contain 850 liters and 680 liters of petrol respectively. As because you'll do it later on, I'm writing it complete words. Find the maximum capacity of a container which can measure the petrol of either tanker in exact number of times. This is for you to solve. Do I give you the answer for the same? You can match it up with 170. This was very simple. You just have to practice this algorithm, finding out applying this division lemma. Thank you.